number 6. Dimensions of a cylinder with a volume of 6 pi cubic centimeters, and that uses the least amount of material. So they also gave us surface area. That's going to be how you find the amount of material that's used. So we're minimizing this, which means we need to use this in order to get this piece all in terms of one thing. So they told me volume is 16 pi, so I'm going to replace the V over here with 16 pi. So 16 pi equals pi r squared h. I'm going to solve it for h because that's the easiest thing to replace. There's lots of r's over here and only one h, so I'm going to divide by pi r squared. And that means I am canceling, pi r squared is canceling it, right? Over here, pi over pi is going to cancel, and so I'm left with 16 over r squared equals height. So now I'm going to go back to my surface area formula, and I'm going to plug in 2 pi r, and instead of h, I'm plugging in 16 over r squared plus 2 pi r squared. Now, before I go to find the derivative, let's go ahead and clean it up a little bit, cancel some stuff. 2 times 16 is 32. One of the r's on top will cancel with one of the ones on the bottom, and I'll have 32 pi over r plus 2 pi r squared. Now, because I want a power rule, I'm going to move that r upstairs and make it 32 pi r to the negative 1 plus 2 pi r squared. That is my formula for surface area before I've taken the derivative. So now let's go ahead and take the derivative of that. So dBr, all of this. So the surface area, derivative of the surface area in terms of r is going to be negative 32 pi r to the negative 2, so I'm going to go ahead and put it underneath, plus 4 pi r. Now we have to maximize and minimize this, and so remember when we do that, we're looking for critical points. So I'm going to take this and set it equal to 0, and then solve. So let's say we set that equal to 0. I'm going to move this to the other side. So that gives me 4 pi r. Actually, I'm not going to do that. I'll tell you why. So minus 32 pi over r squared equals 0. Okay, I'm going to clear the fraction. And if you clear a fraction, you multiply your entire equation by the denominator you're trying to get rid of. So I'm multiplying it all by r squared. That would be this times r squared, this times r squared, and this times r squared. That gives me 4 pi r cubed. It cancels the r squared over r squared. It's going to cancel. Minus 32 pi. And r squared times 0 is still 0. Now I'm going to move everything around and solve for r. Because now I just have one r. Don't have to worry about getting them together or anything. So I have 4 pi r cubed equals 32 pi. Well, I have a pi on both sides. So those are going to cancel. So I divide by pi and they go away. I'm going to divide by 4. So I end up with r cubed equals 32 divided by 4 is 8. Which means r equals 2, because you take the cube root. All right, but it asks dimensions. So now I have to plug my 2 back into this. And that would give you height equals 4. So my dimensions are the radius is 2, and the height is 4.